zone is set between 10 and 15 pounds. 15 psi is 1 atmosphere above normal working pressure, and that means the product will cook quicker and stop oil penetration. On this machine it's set on your main valve at around 13 psi, so that's what it should operate. However, if you don't put enough low density of chicken, it will not achieve pressure. Each machine has a minimum, and I would say it's of this type of machine around 1 chicken, 9 pieces, which is about 1.5 kilos, up to the maximum levels we've mentioned. What happens if the main valve at front, which is the manual relief valve, is set wrongly, or it's blocked up with grease, the pressure starts to go over the 15 psi. There's no way the steam can escape through the manual safety valve here and exit through the condenser at the back, because that's just condensing the steam. So there's a failure device on the lid, the manual relief valve, or safety valve as it's called. This should always operate. You test it, the spring activates. The spring is preset with a plunger, and this will automatically vent 18 to 20 psi. So if you're starting to get steam from here escaping, the machine main valve, which is on the front, the manual release valve, is blocked. So that directs you to here. It wouldn't necessarily go off even if you overloaded product. That wouldn't be the same. This would still be venting. If you overload it, it would be venting steam and, as you just said, oil. So oil will be spraying out the back because you've overloaded the capacity of the machine. The oil level is raised because of displacement of product. It won't affect this. So the only way this would go off is if the main valve is not set correctly, it's not clean. Once the product's loaded, you have to create a seal to stop the steam escaping, and that's why you've got an O-ring here. The O-ring should always be round in shape. If it starts to wear flat, you're going to get steam escaping from the lid, and you won't build pressure. Then you're not going into the green zone and it won't cook correctly. So always check your O-ring. O-rings last about 12 months. They're very, very vulnerable to a sharp knife. A customer or a client may use a sharp knife to remove it. There is a prizing tool supplied with the machine to remove the O-rings. They should be clean, and they should be lubricated with a non-toxic lube, Vaseline type product, or food safety grease. On some machines, older machines, I've seen that the actual well has been worn. They've used steel wool, and what will happen, you'll end up with a groove in the actual well, so check around it to make sure there's no wear and tear, because if there's a wear in the pot, it's the end of life, and that's purely, there's no way we can fix that, but it's purely through wear and tear of scouring it or using the wrong cleaning products to clean it. It should be smooth and round, and then you get a good seal on the O-ring. So check that there's no wear on the pot. The front, this shield is a safety device. Why would you have that on there? For example, if you open this valve while being under pressure, all the steam and oil will escape and hit you in the face. So this shield is just a protective device. It should be in place. If it's not there, it's been broken off, this machine should be condemned, or we should supply a new shield. So it's purely a safety device. And the other thing which is a good safety device on this, you've got a pressure locking lid, and then you can see a bit of that, and now it won't open. So okay. Just behind here there's a cam lock, and there, yep. And when that goes up, it locks in position. So there's no way you can open it. So it's another safety device, but it doesn't affect pressure at all. They do wear, and they're double-sided, so you can turn those cams around, and that notch then is on the other side. So purely a visual check for safety. You check that your valve is working, you check your gauge is working, you check the camera is working, you check the shield is in place. We have a checklist, and that you should have copies of.
Yep, we've got loads.
So we sign off all of these are standard check points, but again, today is about pressure and how we make sure it's maintained. So the manual relief valve has a spring which controls pressure. There's a Teflon tube, and this goes inside the manual relief valve, and by moving the valve in and out will adjust the pressure. It's important where the nut is located, because the more tension, the higher the pressure will become, and the less tension, the lower the pressure will become. This needs to be preset to a specific size as per the manual. It pushes the valve open, and by pushing the valve open, it allows steam to escape through this condensed tube to the condensed box and escape to the rear of the machine. Now we've taken this off. Obviously you see the O-ring is no longer round, it's flattened, so that would definitely be a need of replacement. We've got a screwdriver there. So that's end of life. So it's actually flat there, but it will be round when we put a new one on. So if you can now remove that with a spanner, you can put one spanner there and then release the top.
Okay, stop him filming.
Second part, not the nut itself. You won't be able to do that by hand. No, don't stab your colleague. Got it? There you go. Now there's a reason I didn't undo the nut, because this one's obviously preset. And what I'm interested to see is, what is the preset? So by pushing the valve out, so you can see the exact distance. If you've got a tape measure, you can measure that distance to see all solidify and eventually stop the valve operating. It will turn carbonized, and that is also a problem with these. They need to be cleaned, I would say, every 6 months, but people don't clean them for years. Also check the O-rings, they're not worn, because if that's worn, the steam will escape too early, won't build up pressure. And inside the tube is clean and free moving, but you mentioned you clean that thoroughly, so it's not that.
Yeah, it was bad, we gave it a good clean.
It's really clean.
Yeah, so, okay. What we're going to do now is one other part that can cause that, and that is the lock side. Take that out.
Oh, you can.
Which way round you put this? Now,
We didn't take this off.
No, we didn't.
you didn't. Oh, good. Obviously, you can see the longer area goes into the body of the machine. If you put it round the wrong way, it will go back on.
Oh, it will.
It will.
Okay.
And then
okay.
that will cause too high a pressure, because now that's pushing onto that
Pushing
Teflon.
yeah.
So make sure that that is the way that it goes in. That bush must go in this way, with the longer part into the body of the machine.
Smaller diameter ring.
Yeah, so that's it now. Okay. So what we're going to do now is we're going to set up the valve roll, pressurize it, and see what happens.
Okay. We need another O-ring?
Yeah, we need a new one of these.
I got find one.
And let's give it. I'll give it a clean while you get
This might take a little while because I actually have no clue this is.
Oh, that goes with that kit. It should be in this kit.
It didn't come with the kit.
No.
This is a brand new kit.
It's got a pattern on that.
No, there's no part
It
number.
doesn't.
You don't know that this is now obsolete.
No way.
Yeah, that's obsolete. It's been replaced by this. That's the replacement.
Okay.
Oh, okay, so yeah, that goes like that right
That
there.
goes-
Okay.
So
Okay.
that's now obsolete. So that is your replacement.
Okay.
Does the same thing.
Put that back on there for me.
Okay, I say I'm living 25 years ago.
Living the dream.
I wish I was living 25 years ago.
Goes together. Ready?
So the bush that goes into the machine has a new rubber seal. The old O-ring is removed because that's now been replaced with a full body washer, and that goes into the machine and then bolts solidly to the unit.
Okay. Just.
So what is important is the setup of the retaining ring, that it hits inside here, the welded bar. When you push to closed, it closes the valve, and push open, it moves the rod, which is on the back here, which is welded on, and that pushes open the valve.
Okay.
So if that is also in the wrong place, it's not going to release the pressure.
If it's in the wrong, if it's in too deep, then it's gonna go ahead and escape the pressure.
It's
as
all the
you're-
time,
Yeah.
and if it's too loose, it's not going to open.
So a quick question for you. So when we go ahead and set this to the desired length that it needs to be at, you're just gonna bottom out this right here.
Correct, and lock
Put,
it in.
and then just put a screwdriver on the back of this, just to go ahead and give it a little tug.
That's it.
And that's it.
Set.
Okay, so that is the way that we would always know that you're actually a 1/16 of an inch off your welded stud, your welded bar.
Yeah, that makes sense. And then
Okay.
you view in there. So that's actually moving. So I'm moving it out of alignment, which isn't ideal. So we need to leave that where it was. So if we lock that out in that position, and we'll put it back together and do a pressure test. So by adjusting the threaded screw in the valve, by turning it clockwise or anti-clockwise, you can adjust the distance between this and the release bar. So it must just be touching. So when you push open, it will now open the valve, and it's not loose. And when you release, it should be
Just give
free
that an eighth of
moving.
an inch.
So it's just about touching, which it is there. That's it, it's just touching. Okay, lock that down with a... That's locked, that's locked. So now just check this is not too tight. Open. Yeah, that's fine. And that's locked in position. So if you didn't lock it, then the problem's going to be it's going to move. Take that pan, because it looks like oil. Oh, there's oil in there, and tip it in the machine.
Oh, no.
It's 90% water. It's condensation, which is condensed when the steam escapes from the manual relief valve, condenses in the box at the back, which we've stripped those and they get chucked up with grease, and then condenses on the cool aluminium and then escapes steam. And the water that condenses in the condense box at the back trickles through the tube to the front. So it is water, and you tip that away as it's water. You'll end up with a millimetre of oil on the top surface, but it looks like oil, but it's not. So you could go into their waste oil bin with it, they'll have a waste container. But whatever you do, never pour that back in the machine. It's exciting to watch, I've seen it. Right, so they let that heat up. So heat up from cold. Obviously the lid won't shut unless that's in the open position. You're thinking, why is that bar there? That's an added safety feature. When the bar goes across, you can't open it because it's locking between the lid.
Okay.
All will happen, it will allow steam to escape, but it won't open fully.
Thank you, Shepherd. Sorry. Yeah. Do you staple it for me?
Right. Just let that heat up. It takes 9 minutes from cold, so it's another way to check if you're doing an element.
Okay.
Check.